All right, ladies and gentlemen, so we're opening up 1.4's discussion, and as we talk about 1.4, guys, we're going to just open up a very quick example of domain and range, and then we'll kind of see why we're diving into some of this stuff. So use the following graph to find 1, the domain, 2, f of -1 and f of -2, and then 3, the range. So let's take a look here. So what does the domain mean? Well, the lowest x value to the highest x value. That's what we're trying to identify. Okay, so let's look at this this particular graph. We say it goes as far left as -1 and as far right, all right, as +2. I wanted to put it off to the side a little bit because we have an open circle there. So by having that closed circle at -1, that means that it is included in our actual domain. So at -1, it's included all the way up into you get to a +5, not included there. And so we're not including 5, so we're not going to go ahead and put the bracket. We're going to instead put the parentheses around it. So hopefully that's a little bit review for us as well too. All right, so what about f of -1? What does the y value look like when x is -1? So f of -1 in this example here, it looks like it's going to be at 1. And then likewise for f of 2, what is the y value when x is 2? Well, in this case, when the x value is 2, the y value is at -3. So what's the range? The range at lowest y value to the uppest, or the highest y value that we are dealing with here. And so it looks like in this case we are going from -3 to 3. Both of them closed on in because of the scenarios that we include those high and low y values there. So that's going to lead us on into the game plan for today. The goals are to look into the vertical line test, find zeros of a function. We're going to look into determining which functions are increasing or decreasing, and how to identify even and odd functions. And of course, this will be split up in a variety of different videos. So today we're going to really be diving on into the vertical line test. What is it? All right, it's a way to show a function is a function by its graph. Hopefully that we have heard about the vertical line test in the past. It's simple. A graph is considered to be a function if a vertical line passes through it once and only once, right? So let's take a look at a couple examples here. Vertical line test. Let's check it on out. Boom, vertical line, boom, vertical line. In both these scenarios, the vertical line that I just drew only goes through the function one time. So yeah, we got ourselves a function. Vertical line, vertical line, vertical line. Yes, a function, because it only goes through it one time. But then take a look here. What happens? Boom, 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 boom. We end up getting ourselves a double cross. So no, not a function. All right. So it's a great kind of utilize this little baby test to see by a graph if it is in fact going to be a function or not. And you're going to start really kind of realizing some patterns as well too as you go through some of these. So I'm not going to spend a whole lot of time on the vertical line test. What I want to dive on into a little bit here today is a recap of zeros of a function. Now, a zero of a function, I also want to make sure we are very clear. You may also see a zero known as an x-intercept, a zero known as a solution. They all mean the exact same thing. They are all asking you the question is, what are the values of x that make y 0? That is the question that you are asking yourself. All right, well, let's take a look. We have 3x squared plus x minus 10. For part A, or this very first one, we need to set it equal to 0. So go ahead and find out what these two values are. Well, what do we got? This looks like probably get two options here. It's quadratic, so you could use quadratic formula. You could do factoring. It's completely up to you. I factored this one on already, so let's go ahead and factor this one out. We get 3x minus 5 times x plus 2 equal to 0. So we have 3x minus 5 equals 0. So x equals 5/3. And then x plus 2 equals 0. So x equals -2. So those are the two zeros of that first function that we're dealing with. What about for the g of x equaling 10, the root of 10 minus x squared, where again, you want to set it all equal to 0. What values of x are going to cause it to be 0, the function to be 0? So squaring both sides, you still get 10 minus x squared equals 0. I'm going to go ahead and add the x squared to both sides, root it, and x in this case is going to be plus or minus the root of 10. So once again, we have two solutions in which this is going to provide 0 for us for our function. All right, and then what about our last one? Let me change colors so we're not getting too confused or anything on over here. For our last one, h of t. So we have 2t minus 3 over t plus 5. Again, I'll set it equal to 0. Well, cross multiply in this example here. What kind of a cross multiply? It's really a multiply by t plus 5 on both sides, but it's the same concept, right? And so we end up getting 2t minus 3 equals 0. Add the 3 on over, and so we're going to have 1, 0 in this case when t is 3 halves. All right, so again, you could see it as x-intercepts, you could see it as solutions, or you could see it as zeros of a function here. All right, and that's going to wrap it up for this video. In our next video, we're going to start looking at increasing and decreasing functions.